Welcome back to Math for class 12th. Good morning, student. Today's topic of continuity and differentiability. Chapter 5. Continuity and differentiability. Definition of continuity. You are already studied in 11th class relative limits and derivative, right? So, in this chapter, we introduce the very important concept of continuity and differentiability and relationship between continuity and differentiability, right? We will also learn differentiation of inverse trigonometric function. Further, we introduce a new class of the function called a exponential and logarithmic function, or all others. The definition of continuity. Definition of continuity. First definition is definition 1. Suppose f is a real function. F is a real function on is subset domain of f. Then f is continuous. F is continuous function at continuous function of domain f is real number. Let C be the point on domain f. Domain f. So this C be point on domain f, then f is continuous at. So therefore f is continuous at C if limit x tends to C function of x this equal to function of C. If in this condition lie in a function, that is given function is continuous function. Clear? The limit of a function x at point C and value of the function at point C are same is called a continuous function. Clear? And LHL, left hand limit, this limit x tends to C negative function of x. Clear? And this is equal to limit h tends to 0 function of C minus h minus function of C upon h. This already complete in this. This is also derivative of function x. Clear? At point C. In this type question or this type, we mostly use on this method. Okay. And RHL, limit x tends to C positive function of x, this equal to limit h tends to 0 function of C plus h minus function of C upon h. This is a definition of the. This is also study in the 11th class. Okay, this function. So here LHS and RHL, left hand limit and right hand limit is used in this value. Okay, negative means left hand limit, power C positive, this RHL right hand limit. Okay, RHL equal to LHL is called continuous function. Clear? That is both equal, both limits are equal, then function is continuous. Function is continuous function. Okay? This is a continuous function. Important points. Definition number 2. Definition 2. A real number function, real number function, yeah, real function f is said to be continuous, said to be continuous if it is continuous at every point in the domain. Clear? Domain of f. So LHL, left hand limit x tends to c positive, c negative, function of x, this equal to function of c. Okay, and interval also given. It is type 2 type interval close interval a comma b. So use this, and this function x tends to b negative, and this is also b. Clear? And RHL means right hand limit lie in a first point. Limit x tends to a, this is b, function of x equal to function of a. This is a second definition of a function. RHL and LHL do not make the sense. This is the consequence of the definition. If the f is defined at one point, only one point, one point means singleton point. Yeah, one point, that is if it is singleton point, okay. This important points are here. Important point, yeah, point for competition. Number first, the points where constant function of x equal to k is a constant. Point is k is continuous function. Clear? The point function is constant, this is also continuous function. Second point, every polynomial function is continuous function. Clear? Number third, important point, every polynomial is a continuous function. Every differential function is continuous, but converse is not true, means continuous function is not a differential. Clear? Every differential is continuous, but continuous is not a differential, that is not fixed. Okay, the sum difference product question of continuous function are continuous function. Sum difference, product and quotient function is continuous function. For example, f, you are already studied in 11th class, f plus z and minus f into z and f of g, f of g, this type question. Plus minus, multiply and divide. Our question Rolle's theorem, then Rolle's and mean value theorem. This mean value theorem are continuous. Means these theorem lie in a continuous function. Continuous function. Clear? The set of mind. So in closed interval a comma b, Rolle's theorem formula. You already next exercise. This formula already complete in this type. F dash of c equal to 0, then f of a equal to f of b. This is a formula. And MVT, mean value theorem, in closed interval f dash of c is equal to f of b minus f of a upon b minus a. This c, where c belongs to closed interval a comma b, means this type, means c, a is less than x is less than b. You can say a is less than c, x means c, so this c. Okay, open interval means in between a and b, not a and b. Okay, c point lie in between a and b, not a or not b. Means c is not equal to a, c is not equal to b, c only lie in between a and b. Okay, so now let every rational number, next point, every rational number is continuous. Rational number, rational function, you can say function, you study only function. So rational function is continuous function. Clear? Next, first example, the function of x equal to 1 upon x. If x is not equal to 0, then it is continuous. Okay, a competition type question. Number 2, same, function of x equal to 1 upon x. If x is equal to 0, then it is not continuous, because 1 upon 0 equal infinity, plus infinity and minus infinity. So both in condition infinity is not a function. Not a function means not a real number. Okay, not lie in the real number. Real number not in infinity, positive or negative. So that is, it is still not a continuous function. Let exercise. Okay, so let here exercise 5.1, question number 1. Question 1, can example and some points are very left, no? Okay, theorem number 2. Theorem number 2. Theorem number 1 is given also some product and difference of the functions. This theorem number 1 or theorem number 2 and new cases. Suppose f and g two function, important for g is continuous function. Okay, g is continuous function such that f of g is defined at C point. At C point, if g is continuous at C, g is continuous at C, and f is continuous at g of C, then f of g is continuous function at C. Okay, so suppose function of x equal to sine x square. So let sine g of x equal to sine x. Okay, this type question. And h of x equal to x square. So putting a g of h of x function, can find g of h of x. We already studied in chapter 1 fog off type question. Okay, so g h of x equal to x square, or g equal to sine x square. Okay, this type question already is, therefore it is continuous function. In this form also clear. Okay, given question also verified. And question number 1, exercise question number 1. Firstly, question number 1, prove that the function 5x minus 3 is continuous at x equal to 0 and x equal to minus 3 and x equal to 5. 3 points are given. So firstly question, function of x equal to 5x minus 3. This is a polynomial linear, so this is also continuous in this type question. Okay, so let function of c means x, first case x equal to 0, limit x tends to 0 function of x, this is equal to function of x equal to limit x tends to 0 function of x 5x minus 3, putting 0, 5 into 0 minus 3 equal to minus 3. Okay, and function of 0 means function of c equal to 0, so function of 0 equal to 5 into 0 minus 3 equal to minus, both are equal. Limit x tends to 0 function of x, this equal to function of c. Okay, equal to minus 3, it is continuous. This type question solve this method, continuous function. Okay, every point lie in f, that is x equal to 0 is coincides on f is continuous function. Second case, x equal to minus 3, so limit x tends to minus 3 function of x, limit x tends to minus 3 function of 5x minus 3, putting this value minus 3, 5 into minus 3 minus 3, minus 15 minus 3 equal to minus 18, and function of minus 3, putting this value in function, so 5 into minus 3 minus 3, minus 15 minus 3 equal to minus 18, both are equal. It is continuous function at x equal to minus 3. And third case, x equal to 5, so limit x tends to 5 equal to limit x tends to 5, 5x minus 3, 5 into 5 minus 3, 25 minus 3, 22, function of 5, 5 into 5 minus 3 equal to 22, it is continuous. We have seen x equal to 0 at x equal to 0, minus 3 and 5 function is continuous. Clear? Function is continuous. This type question. And next type question, suppose question number 3 is given, examine the following function is continuous function. Question number 3. First A, function of x equal to x minus 5. So this type question already solved this question number 1 type. So limit, only find limit function of x, any definition 1 type. X tends to examine, so this find only function of x is a continuous or not continuous. Okay, so x minus 5, this is function is very important. So no value is given, so x minus 5, so this is a 0 at point 0 function type, or at this type question at 0.53 no value, so c belongs to belongs to real. Okay, so that is c be the real number. Clear? So at point c, function limit x tends to c, so this is equal to limit x tends to c, x minus 5, this equal to c minus 5, and function of c equal to c minus 5, both are equal. So therefore f is continuous function at x equal to c. So every real number, that is c coincides on f. Clear? So coincide means on f belongs, c is also function, belongs to function mean domain, it is continuous function. Clear? This type question. And second, already solved this type question number c part. C, this is a polynomial function, x square minus 25 upon x plus 5, this type question. So we are simplifying. Okay, we are already solved in this in the 11th class. X square minus 25 is simplest form, x minus 5 and x plus 5, x square minus 5 square, e plus b minus b upon x plus 5, x plus 5 cancel, x minus 5. This is question number, first part of question number 3. Clear? See question number 3. Okay, solve कर लो. Next question number 4, 5 simple. So 5 question number 5 important question. Is the function, this type question is coming in the board examination or competition. Is the function f is defined by x5 if x is less than 1 और x is greater than 1. ओके, ऑलरेडी न्यू एक्स्ट्रा एक्सप्लेन कर देता हूँ मैं आपको. इन दिस केसन LHL लाई इन x is less than means left hand side, right hand limit lie in greater than, x is here greater than a and greater less than. Clear and perfect. LHL greater less than a, less than a. RHL right hand limit lie in greater than, function value means a. Let's see a. So a is real or non real. So LHL less than condition and greater than condition lie in RHL value. Clear? And equal condition have both, and x equal to a have LHL and RHL. Means both lie. LHL find करना, RHL find कर, both are equal, that is continuous. In this case conditional, in this case continuous, in this type question, and this condition are different. Okay, so less than and equal and greater than. So less than and equal, so less than lie in lower limit in this function, of greater than 1 is lie in RHL means right hand limit in this function. Okay, constant function is also continuous function. So definition point very important. Okay, and clear. Next this function, तो केस बना लेते हैं इसमें. केस फर्स्ट, दिस function of phase first, sorry, x is less than 1. Okay, x is less than 1, so limit x tends to 1, x tends to x less than condition, so x less than to 1, function of x, this is equal to limit x tends to 1, function less than conditional function x, like x equal to 1, putting only 1, and function of 1 equal to 1, clear. So it is continuous function at x is less than 1. Clear. Next case number second, verify this. X is greater than 1, x is greater than 1, limit x tends to 1, function of x, this equal to limit x tends to 1, function limit greater than, so greater than lie in 5, constant function, 5 is constant function, this is also 5, so therefore function of 1 equal to 5, it is continuous function. Or you can directly solve without solution, you can solve a continuous function, because 5 is the constant, the constant function is, every constant function is continuous function. Clear. So that at x is less than, sorry, greater than 1. In case number third, x is equal to 1. Clear. X is less than equal to 1, so in equal condition, less than and greater than, clear, and equal, in equal condition, so find LHL and RHL. So this is a line, find LHL, this limit x tends to 1, negative means left hand side of function, of this side RHL find, the limit x tends to 1, positive power, function of x, this equal to left hand limit negative, left hand limit lie in first, x tends to 1 in x, this is equal to, putting 1, and this value equal to limit x tends to 1, positive lie in second function. Function is constant function, 5 equal to 5. LHS equal to 1 or RHL equal to 5. It is not equal to, left hand limit is not equal to Rn, which is equal to discontinuous. Clear? It is not continuous, not continuous. Function at x equal to 1, that is 1 is not constant, so that is without 1 is also continuous function. Clear? This is a not continuous function at x equal to 1, is less than condition continuous, greater than condition continuous, but x is not equal to means this point is blank, means power point is free. Clear? Online you can say this type 0, right side positive and this side negative, so use LHL and RHL. No fix, this is a initial point, this is a make a initial point lie in this side and this side also. The initial point to left side is LHL and right side to RHL. Clear? So limit is not continuous, that is discontinuous function at x equal to 1. X equal to 1, so you can say a continuous function, find continuous only, right? Question is clear. But if discontinuous function x equal to 1, but if less than greater than continuous, so continuous function interval real to -1. ओके, इन दिस फंक्शन में लाई करेगा, जो रियल से -1 को हटा दो तो बाकी अदर फंक्शन में क्या है, वो कंटिन्यूस है, 1 में ही तो कंटिन्यूस नहीं है, दैट इज वो डिसकंटिन्यूस है, तो रियल 1 है तो 1 में से -1 कर दिया जाए तो वो कंटिन्यूस फंक्शन होगा. क्लियर? Okay, solve this questions question number 5 and question number 6 to 13 are same, बल्कि 13 are same. So this time question solve this. Okay, for question number 1 to 5 are solved and next exercise 6 to 12. Okay, thank you.